Hello, Accelerated Chemistry students. This is Miss Krista Foley, and this is your Chapter 6, Section 2 notes all over classifying the elements. So let's start talking about how we're going to read the periodic table. Some periodic tables usually display symbols, names of the elements, along with information about their structure. Your periodic table that you use for my class does not include the element names or a couple of the other things that we're going to talk about, but that's okay because you guys don't need that for my class. However, on some periodic tables, those pieces of information may also be included. So this figure shows one square from a detailed periodic table of elements. The center is the symbol for aluminum, Al. The atomic number for aluminum is 13. That's written above our symbol. And the element name and the atomic mass are below the symbol. There's also a vertical column with numbers 2, 8, and 3, and that indicates the number of electrons in each occupied energy level of an atom of aluminum. And we can break that down even further and say how many electrons are in each sub-level based on when we write the electron configuration for every element. Now, the symbol for aluminum is printed in black because aluminum is a solid at room temperature. Remember the periodic table in the back of my room. It has multiple different colors for the different elements on there, and we're going to go through what those mean right now, and I want you to keep that in mind as you're looking at the periodic table in the back of my room. Now, the symbols that are gases are in red, and the symbols for the two elements that are liquid at room temperature, mercury and bromine, are blue. Now, there are some symbols that in this picture are gray, and in the periodic table in the back of my room, they're actually outlined in white. And remember, these are because they were not found in nature, and they were synthesized in a lab. So now let's talk about the individual element groups. In Section 1's video, we talked about metals, nonmetals, and metalloids and their properties. Let's dive in a little deeper and look at the individual groups of elements. So group 1 is known as the alkali metals. Group 2 are the alkaline earth metals. Group 3 through 12 are your transition metals. Group 17 is your halogens. 18 is your noble gases. And hydrogen, we're going to talk about that one all by itself. Now, this periodic table is very similar to the one that you have in class, and we are going to color code a blank one so that you know where all of these groups are located. So let's first talk about group 1, the alkali metals. They have one electron in their outer shell, and we say that they have one valence electron. They lose that one electron to form +1 ions. They're extremely reactive with water, and their reactivity increases as you go down the column. So that means the most reactive metal in group 1 is francium. Group 2 are called the alkaline earth metals. They have 2 electrons in their outer shell, or 2 valence electrons. They will lose these electrons to form +2 ions, and they are fairly reactive with water. Group 3 through 12 are what we call our transition metals. They're the least reactive metals, but the big thing that they do is they form colored ions in solution. So when these metals are dissolved in water or dissolved in a solution, they give that solution color. So let's talk about group 17, which is the halogens. They have 7 electrons in their outside shell, or we can say that they have 7 valence electrons. They will gain 1 electron to form -1 ions, and the most reactive nonmetal is francium. So it's kind of opposite of the most reactive metal. And group 18 are what we call the noble gases. They are unreactive or inert. They're chemically stable. They have a stable octet, which means that they have 8 valence electrons in them. The only exception to this column is helium, because helium only has 2 electrons, but it's in the first energy level, so that means that it only needs 2 electrons to fill that energy level. And these are all monatomic, which means that they do not partner up with anybody. They exist in nature by themselves. And then the last one we're going to talk about, hydrogen. Hydrogen is not officially part of a group. It is a nonmetal and a gas at STP, or standard temperature and pressure, but it's located in group 1 because it has one valence electron in its outer shell. So now let's talk about electron configurations in groups. Electrons play a key role in determining the properties of the elements, so there should be a connection between an element's electron configuration and its location on the periodic table. This is going to be a quick review because we talked about this in chapter 5. So elements can be sorted into noble gas, representative elements, transition elements, or inner transition elements based on their electron configurations. So let's start off with the noble gases. So the electron configuration for the first 4 noble gases are listed below. You should know how to do this. But if we were to look at the last part of it, what is highlighted, the S and P sublevels are completely full. And so this is what gives its noble gas configuration to be stable and non-reactive. So helium has a full S, neon has a full second energy level, argon has a full third energy level, and krypton has a full 4s and 4p. Now let's talk about the representative elements. This figure shows a portion of the periodic table containing groups 1a through 7a. The elements in group 1a through 7a are often referred to as the representative elements because they display a wide range of physical and chemical properties. Some of the elements in these groups are metals, some are nonmetals, and some are metalloids. Most of them are solids, but a few are gases at room temperature, and one is a liquid, and that is bromine. So when we're looking at these representative elements, the ones that are found in group 1, they have 1 electron in the highest occupied energy level. And again, those are all highlighted in the electron configurations. Now remember, we talked about this. Lithium is in the second row on the periodic table, the S block of the periodic table, and it's the first one in that block. Sodium is in the third row on the periodic table, the S block of the periodic table, and the first one in there. And potassium is the same thing. So these are ways that we can, like we said in the last chapter, write the electron configurations based on the location of the elements in the periodic table. So if we were to look at group 4A elements, so that would be like carbon, silicon, and germanium, the same is true. All of these elements are found in the second column of the P block. And so their outer electrons are going to be, if it's carbon, they're in this, carbon's in the second row. In the P block section, it's the second one over. Silicon is in the third row on the periodic table, the P section, the second one. And germanium is in the fourth row of the periodic table, the P block, and the second one in. So remember, the place that these elements are on the periodic table is very specific to that element, and no other element can go in that space except for the element that is already there. So now let's talk about the transition elements. In the periodic table, the B group elements are separate the A group on the left side from the A group on the right side. And the B group elements are referred to as the transition elements. And there are 2 types of transition elements, the transition metals and the inner transition metals, and these are classified based on their electron configurations. So the transition metals are the group B elements that are usually displayed in the main body of the periodic table. In atoms of transition metals, the highest occupied S sublevel and a nearby D sublevel contain electrons. And these elements are characterized by the presence of d electrons, of d orbital electrons. So remember, we said all those transition metals will have d orbitals as their last part of their configuration. The inner transition metals are the elements that appear below the main body of the periodic table. And they are going to have elements that have the S sublevel as well as the F sublevel in their outer shell. The inner transition metals are going to be characterized by the presence of electrons in F orbitals. Now that should all be a review. We used our periodic table when writing electron configurations in chapter 5. So before scientists knew much about the inner transition metals, people referred to them as rare earth elements. This is misleading because some of the inner transition metals, like uranium, are more abundant than other elements on the periodic table. So notice that some of the inner transition metals are not found in nature. These elements were prepared in laboratories using methods that we talked about in chapter 5. So those are the ones that are on the back wall of my classroom that are outlined in black. And that concludes your chapter 6, section 2 notes all over how we classify the elements. And remember, as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbooks, resources, CD, and pearsonchem.com. Thank you so much and have a good night.